Welcome to all to this LMS video lecture series program. First BSc Mathematics elective, first semester, Mangalore University. We are in session 5. In this session, we are going to see parabola. Its definition, various terms like focus, vertex, axis, directrix, different forms of equations of parabola, and application of parabola in economics. Let us see first definition of parabola. A parabola is the locus of the point such that its distance from a fixed point is always equal to its perpendicular distance from a fixed line. Here fixed point is called focus of the parabola and the fixed line is called directrix of the parabola. Now we shall derive equation of a parabola when its axis is vertical and vertex at origin. Suppose its focus is at the point 0, a, which is a point on y-axis. Then equation of directrix will be y equal to minus a. So consider a point, say P, x, y on the parabola. Then draw PM perpendicular to directrix. Let it meet x-axis at n. Join S and P. Let the coordinates of S be 0, alpha. Now distance from O, that is origin, to S is alpha, that is also distance from O to directrix. See, this is a point on the parabola, so its distance from fixed point and fixed line are same. So we have taken this length equal to alpha, so therefore this length also equal to alpha. This is drawn perpendicular, so therefore Nm is equal to alpha. And here coordinates of P are x, y, so therefore Pn is y. Y coordinate of a point is its distance from x-axis. So Pn is y, Nm is alpha. Pn is y, Nm is alpha. When Pm splitted into Pn plus Nm. So we get y plus alpha. Ps, distance from P to S. In first session we have seen when coordinates of 2 points are known, distance can be written in terms of their coordinates. So distance SP is x minus 0 whole square plus y minus alpha whole square, square of the distance PS. Now expanding y plus alpha whole square, we get y square plus 2 alpha y plus alpha square. Expanding y minus alpha square, we get y square minus 2 alpha y plus alpha square. Here y square cancelled and alpha square also cancelled. So we get 4 alpha y equal to x square or y equal to 1 by 4 alpha x square. Let a be 1 by 4 alpha. Then equation of parabola takes the form y equal to ax square. So here the point of intersection of the parabola and x-axis or axis of the parabola, this is axis of the parabola, that point is called vertex. That point is called vertex. The line perpendicular to directrix and passing through the vertex, that is called axis of the parabola. So since axis is vertical, directrix is horizontal. And also another point is this curve is symmetrical about y-axis. Symmetrical about y-axis. Now there are other forms of equations of parabola. Y square equal to 4ax. In this case, focus at a, 0 and the vertex at 0, a and directrix x equal to minus a. Y square equal to 4ax. Focus minus a, 0, vertex at 0 0 and directrix x equal to a. X square equal to 4ay, focus is 0 comma a and vertex 0 comma 0, directrix y equal to minus a. Fourth form is x square equal to minus 4ay, where focus is 0 comma minus a greater than 0, and the focus and the vertex 0 comma 0 and the directrix y equal to a. So these are the observations. When the equation has y square term axis of symmetry along the x-axis, when equation has x square axis is symmetric with respect to y-axis. When axis of symmetry along the x-axis, it opens right when x is positive, coefficient of x is positive, it opens to the left if coefficient of x is negative. For axis of symmetry along the y-axis, it opens upwards if the coefficient of y is positive, it opens downwards if coefficient of y is negative. The equation of the parabola with axis vertical and a greater than 0, then it can be used to represent U-shaped marginal curves. Now, what is the application of parabola in economics? Parabolic curves can be used to represent various types of relations in economics. Some instances of its use are given below. A part of the curve can be used to represent a demand relation. The arc AB of the curve in each of these figures can be used to represent a demand relation, transformation curves, etc. See, we have here, if the demand relation is linear, then we know that P equal to A minus Bx. The total revenue curve is given by total revenue equal to Px, where P is price, X is number of units of the commodity. So when P is substituted by A minus Bx, it will form Ax minus Bx square. So it is a quadratic function of X. Therefore, curve is parabola with the axis vertical. Now, sometimes you want to need to find coordinates of vertex. So for that we write TR is equal to minus B in bracket x square minus a by b x. To complete the square, we add and subtract a square by b 4b square. See here, minus of plus a square 4b square is minus a square b 4b square, and this cancels. So these three terms will form a square, and that square is x minus a by 2b. So bring this a square by 4b left hand side. So this is a parabola with vertex at a by 2b comma a square by 4b. Since coefficient of x minus a by 2b square is negative, here this is negative, the axis will point downward. Also note that there is no constant term in the equation of total revenue, and thus the curve passes through origin. Obviously, the arc of curve is lying in the positive quadrant is taken as total revenue curve. So in next session, we are going to see problems related to application of parabola in economics. Thank you.